friends. How are you all today? Have you ever wondered what are random variables and how they can be used in engineering? It's coming up right now. I'm Prashant from Dharini Academy of Technical Education, Bengaluru. We'll be discussing about random variables now. Before we start with the exact concept of random variables, let's look at some of the basic concepts that are required immediately to apply inside the concept of randomness. Okay, so those concepts are directly coming from what you call as a probability. Okay, right. So we know that the probability is related with the result of any experiment whose results you cannot determine exactly, right? We know some range. Okay, there will be some event whose that event has several possible results, and we want to find out what is the probability of an event. Okay, so this is related to any event. Directly it is related to an event. So how do you define that? That is what is our first concept. We need to recall P of E is denoted as a small p also. This is nothing but the number of favorable cases whole divided by the number of possible cases. Right? So, for example, you are tossing a coin. Probability of getting a head is an event. Getting an answer as head is an event. So, we know that its probability is given by favorable cases. Favorable is only one head possible out of two cases, right? So denominator is 2, so 1 by 2. Very simple. Okay, if you want to give a notation, the numerator I'll call as m, denominator I'm going to call it as n, right? Okay, so if there are m possible cases out of n total cases, right? So the favorable cases are given as m, total cases as n. Then we know that there are non-favorable cases. That is, what is the number of non-favorable cases? This is m minus n. Is it m minus n? Sorry, it should be n minus n. Correct? N is bigger, so this has to be n minus m. So there will be n minus m number of, right, cases which are non-favorable. Okay, this is n minus m, right, as the number of non-favorable cases. Okay, so if E is the event, then we always try to denote the non-favorable event. Okay, E is an event. I write event as E, right? So this implies we can always write the non-favorable event, right? This non-favorable event is always denoted as E bar. Okay, so I always can write probability of E bar. Okay, you can always denote this as it's actually 1 minus p, right? But I'll write it as maybe a q. You can write it as a q, right? So this q is actually equal to the n minus m, my mistake. This is n minus m over n, right? So I can write n minus n divided by n as 1 minus m by n. So I know that the q is always 1 minus p, right? Okay, this is what we already know. Also, it's a very well known fact that the P plus Q equals to 1. Right? Okay, all these things we know. Right. So then I think we studied the basics of probability, that maybe we can calculate any example such a way that what is the probability of getting a king, okay, when you draw a card randomly from pack of cards, right? I know that I have 4 kings possible out of 52. So 4 by 52 is 1 by 13, right? So such example we might have solved, right? Okay, then when we go to the randomness, I'll discuss only the topics required to randomness. Okay, others I just leave. There is what is called as mutually exclusive events. If you recall, right, I'll try to define the correct. So mutually exclusive events, right? This means if you have two different events producing random outputs, okay, the happening of one event, right, prevents the simultaneous happening of others, right? Mutually exclusive, right? So in a mutual exclusive case, right, I can write the notation as P of A. I can write or A or B. This is nothing but, right, P of A plus P of B. There is no, this event cannot happen simultaneous, right? So that's why this is one case. At the same time, you can actually write P of the A. This is and B, and occurrence. It means it has to be a P of A multiplied by P of B. Okay, this, yeah, these concepts we have to use. Okay, all right, let's go ahead of this, and now I directly bring the concept of random variable. Okay, so why do you need a random variable? What is the requirement? Let's go through this very quickly, and let us assume that we are conducting an experiment. All right, let us say the experiment is once again the same. This is head and tail. You are going to get a result like this. This is when you throw a coin once. Okay, what I do, I want to go for slightly complicated uh, experiment, possibly, right? I'll call it as S1. Okay, I'm throwing the coin twice, right? So you see that the result, when you throw coin twice, possible results are when you are throwing 2 coins simultaneously, that's also fine. So the results are head and head. You may get head tail, you may get tail head and tail tail. Straightforward, this is fine. Now I see that my result, the space allocated for the result is increased, right? Previously I had just 2 possibilities, now I have 4 possibilities. Okay, maybe you can extend this further to get a next level of results, like throwing 3 coins simultaneously or throwing a large number of coins simultaneously. I know that the possible results are head 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 dot dot dot, like head 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 tail head 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 tail tail tail, like that. I have so many number of options possible. When this is the case, right, when I want to conduct this experiment through an algorithm in a computer, right, these values, entering these values into the computer becomes very difficult, right? Because you see that if it is head and tail, no problem, simply HT. But when you are throwing, assume that you are we may not physically do the tossing of 50 coins simultaneously, but in practice, when you go for engineering problems, when you are trying to solve some engineering problems, like maybe I want to simulate the path of an aircraft, fine. So there are several parameters, right? Like one coin is one parameter. You have 10 20 parameters altogether. Okay, so maybe a height, maybe the velocity, maybe the xyz coordinates of earth, maybe, right, uh, maybe the wind velocity, many things you need to consider, right? And they are random, it can be any value, correct? So depending on that, when you conduct the result of such experiment and you want to enter it into a computer through an algorithm or for running simulating some algorithm, these values, the entering of these values into the system becomes very difficult. Plus, if at all it is something like the results are the text based, like yes, no, and maybe, right? Rain, no rain, and maybe the environmental condition, it's cloudy or something like that. If writing those things, right, into a computer program, right, is difficult. That's the first problem what we are facing whenever I'm dealing with the results of a random experiment. Okay, now, so what we are trying to do here is that, what if each result of a random experiment is converted into a real number? Okay, for example, right, I will define an event. This is the possible outputs. Okay, this is the total possibilities of whatever outputs you may get when you try to do this experiment. But I'll try to define an event. Now the event, let me call the event as x. So I'll call this as event. So x is nothing but, right, I'm trying to find an event where I want to obtain, right, the number of heads. If that is the case, right, see, your result is like this. X could be, when you get 2 heads, your answer is 2, correct? When you get HT or TH, number of heads is 1. Okay, when you get tail, see, your answer is 0. Indicates what? My problem is solved. See, I just have to enter number 2 when I want to represent my result is HH. Entering a number 2 into the computer is very simple, correct? We can deal with numbers easily rather than dealing with the mnemonics like HTTH, yes, no, all those, correct? So see, the HT or TH is directly converted into a number 1. TT is directly converted into 0. So simple, right? So we have a sample space denoted by S, and there is an event X which converts my sample space S into some numbers. So what is this? This capital X is what is called as a random variable. So this is what is my random variable, right? Random variable always converts result of any experiment into some real numbers. I'll write that later. That's very important. So this is a random variable. I understand. So why this is random variable? I have to justify. You see that it's a variable. It can take any value, either 2, 1 or 0. Okay. It's a variable. It's very clear now. Why it is random? It is definitely random because my result is random. When I throw 2 coins, I don't know what I'm going to get. But I am very sure that I'm going to get one of these 4. Right? So because of these 2 reasons, I'm going to call the capital X, which will take one of the 3 possible numbers, as a random variable. Okay, right. Let me give another example. So very similar to this, I can also call the random variable as the total number of tails. Okay, fine. That's also going to take the same values, but in a different way. So in that case, the 0 will be replaced by 2. 1 is 1. The 2 becomes equal to 0 over there. I can actually define the y, right? Definitely. So if you want to define y as, right, the number of tails, right? This means your result could be, when you get HH, it is 0, this is 1, this is 2. Okay, fine, absolutely fine. We are converting the S sample space into a series of numbers. The numbers depend upon what result you get as a right, when you conduct a random experiment. So let's go to another example, right? So here I try to define my sample space like this. Okay, sample space is equal to, this is mathematical notation, any x comma y such a way that the x and y, uh, I'll write in words, okay, x and y, sorry, x and y belong to 1, 2, 3, 4, 5, 6. Okay, this is a sample space. Now, can you tell me how many entries are there in this S? If I expand and fill this completely, how many S will be there? It's like you write xy as 1 1 1 2 1 3 1 4 dot 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 1 6, then 2 1 2 2 2 3 2 4 dot dot dot, like that. I fill up all the possible entries. The last entries will be 6 comma 6, like that. If I fill, right, I know that this S basically has 36 entries, right, from 1 comma 1 dot 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 till 6 comma 6, 1 comma 1 1 comma 2, it will come. It's not like 1 1 2 2 3 3, it's in that way. Total 36 entries I have. So let me define an x is equal to, right, small x plus y. Okay, if this is my case, can you tell me, right, what is x, right? If x is equal to, capital X equal to a random variable which is nothing but small x plus small y, can you give me the values now to fill this? What is the minimum number that is possible here? Minimum number that can come as a result of adding two numbers is 1 plus 1, correct? 1 plus 1. So this number will definitely, it's not 1, it's not going to start from 1, it will be starting from 2. Right. Then the next number will be next 1 plus 2, right? That is 3. Right? Like that. I get 1 plus 3, 1 plus 4, 1 plus 5, 1 plus 6, which is 7. Definitely it is going to come. Then I can see that, right? The biggest number is possible when you enter it as 6 plus 6. Correct. So all the numbers will come 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you see that this result is being converted into a random set of variable, right, which contain real number. That's why this is also called as a random variable. So x is a random variable, right, that might come because of adding any of the two numbers in the range 1 to 6. It's random because we definitely don't know what we are going to add. We just said that, okay, x and y belong to these two cases. But, right, when we add, what might come, we don't know. So because of all these reasons, right, we need the random variables for basically two things. One, to make entering a complex result which is a mixture of text and maybe some numbers, etc. We want to convert that into real numbers so that this can be entered easily, right? So we solve that issue by simply defining a random variable which converts result into series of numbers. Okay, now, so basically if you remember, we have two types of random variables. Okay, the first type is nothing but it's a continuous RV. I just use a short form for that, continuous RV. It means the x takes all the possible values from minus infinity to plus infinity. Any value it can take, right? So continuous RV means x, right, takes continuous values, right? Real values are possible. Okay, I'll write all real values are possible. Okay, it is possible to get any value like that. So can you give me an example, right? Any example, it's possible to, let's define an event. So event x could be, right, I want to get any possible number, right? It's not just discrete like 1, 2, 3, 4. No, no, no rule like that. For example, maybe I'm measuring the weight, weight of maybe objects. So here I am simply defining object, which means it can be anything. It can be a book, it can be my calculator, it can be my laptop, it can be anything. It can be the weight of the pen I'm holding, right? So you see that this will definitely come as a real number only. There is no rules that it has to be. Yes, yes, anything, any value. So observing the value you read on a voltmeter, anything, right? The speed of a vehicle, correct? Anything, each of these, right, what we are talking now corresponds to a continuous random variable. Okay, now, so let's go ahead, let's go to the second case, that is called as the discrete random variable. All right, so this is discrete random variable. Now what does it mean? It has to take, right, only a finite, it's not like, in the sense it can take all the possible infinite values are possible, right? But it has to take a countably infinite. You should be able to count, but there are infinite possibilities. Okay, so x takes countably infinite values. In a sense, even if you say that it can take only the whole numbers 1, 2, 3, 4, I am able to count. But what are the total possibilities? You can take a value from minus infinity to plus infinity, all real numbers, correct? Not real, all whole numbers, right? So you are able to count, but there are infinite possibilities, right? So the example could be, right, we know already, we discussed tossing a coin, right? Number of heads coming up, throwing a die, okay, and what numbers might come, right? Finding the, right, whether it is even or not, something like that. Okay, chance of getting even and odd number, all those things we know. So I'll just write the example of tossing coin. Okay, you are going to throw a die, right, and finding up something related to it. It's fine, right? Okay, let's go ahead. And now our objective is to recall the probability functions associated with the discrete first, and maybe we'll go for the continuous later. Okay, so we need to recall something so that we use them in the random variable concepts. Okay, so let's just try to recall. All right, so I just write the discrete probability function and the probability distribution function, okay, PDF. Now I know that I have a x which is a random variable. This actually takes several possible values, correct? This can be x1, x2, dot dot dot, up to maybe xn. There are n different possibilities, right? Which I would like to write it like xi is an entry. Okay, this basically contains several number of xi's. Capital X is the whole variable, small I is a sample of that random variable. So this is what we write here is a sample of, right. Now we know something related to this. What is that? The first property which we already know is that this probability p of xi, probability of getting any xi, is always greater than or equal to 0, correct? And we also know that summation, this I varying from maybe 1 to n, the sum of p of xi, when you add all of them, the probabilities, what you get? You get 1, right? So what do you mean by this p of x? The p of x is what we call as the probability function. Okay, this is a probability function. All right, fine. So we are able to recall this. So p of x is actually, the meaning is, right, whenever I say p of xi, I just try to make sure that we recall this. P of xi, or some of the books will say this as pi. Pi is nothing but what is the probability that the capital X takes the value xi. Okay, in the sense, if number of heads equal to 2, what is the probability that you get 2 heads? That's the meaning, right? So anyway, we cannot write that sentence wise inside the computer, right? So you just write a number 2 indicates that, okay, I'm getting a number of heads equal to 2. That's all. Okay, all right. So anyway, we are able to recall all this. Now we go to another important function that is called as probability distribution. Okay, so probability distribution is pdf. Probability distribution function is denoted by, right, if you remember, this is, right, you call it as capital P of x. Okay, this PDF is P of x, that actually, or I'll give another notation that's also very useful. This indicates that probability that x takes a value less than a given x, right? I have the values like 1, 2, 3, 4. What is the chance that probability is less than 2, right? When you have 1, 0, 1, 2, 3, 4, when I say 2, it means less than all the values less than 2. It means 1 and 0. What is the chance that your variable is reaching this? This is how it is defined. Some authors will call it as small f of x. All are same. Okay, don't get confused. So I'll write that now. So how do you define this? This is nothing but, right, f of x is equal to probability that capital X is less than, sorry, I wrote only less than, it's actually less than or equal to. Okay, so less than equal to small x. This is nothing but summation. I have to take the sum from I being 1 till x. It's not till n. If you add till n, I know the answer, right? If it is till n, it is 1. Okay, so I'm not considering till n. I'm simply considering till any x, because this is the condition. It's equal to or less than x means all the values starting from 1 to x I have to add. Okay, so addition of this happens with respect to all the p of xi. Okay, when it is I equal to 1, x1, p of x1 plus p of x2 till that value x comes. Okay, so not only this x is what? X is an integer. That's why this is called as discrete. It's a discrete case. I'm still, I think I just wrote the discrete. We are going to discuss the discrete first, right? So that is discrete part. So that's why I'm specifying the condition that this x has to be discrete. Okay, right? Now let's go further. Fine. So let's define another part here that is called as a CDF. CDF is actually cumulative distribution function. Again, this is related to the given function itself. Okay, now what we are trying to do here is that we are trying to represent the CDF in a specific case. All right, here, okay, I think I wrote PDF first, then this f of x is PDF, sorry, this is the CDF, f of x is CDF. Okay, right, let's try to define what is called as the mean and variance. All right. So what is the mean? How do you calculate the mean? Mean is nothing but you calculate the frequency of occurring any event, that is summation of fi into xi whole divided by the total frequency summation of fi. Okay, so fi is the frequency, right? Ith event occurs f times, that is fi. Like getting a out of my 10 experiments, 4 times I got heads. So frequency corresponds to that ith event becomes 4. All right. So like that we try to calculate. Okay. All right. Then we have a part called variance. So this is what is called as mean, and the sigma square. This is the variance. It's f or fi into xi minus its mean is x bar, it's a square whole divided by it's the summation of fi. Are you okay? So we always try to calculate it in this fashion. Yeah, this is given, this is called as the variance. Okay. Alright, now next what we are going to see is, okay, this is the basic required function. Now let's try to define the same mean and variance in terms of say discrete distribution. Okay, so mean is denoted as, I'll give another notation. Mean mu is equal to summation over I. Okay, this is xi into p of xi. Okay, p of xi is the probability, xi is the value of that function, that variable which it is taking. If it is 2, it is 2 times. If it is 1, it is 1 time. Okay, and the variance for discrete, normally we write it as capital V. Okay, continuous it is sigma square. Fine. So anyway, we just have to remember the point, but equation is important. So this is xi minus mu the whole square into p of xi. All right. So mu is my mean, xi minus the mean whole square into p of xi. So if you recall, there is one more term called as the standard deviation. So the standard deviation is denoted as sigma because variance is sigma squared. So this is nothing but root of that v. Okay. Okay. So let's consider one scenario where we have x and p of x are known. These two are known to us, and let's say the values are like this. X takes the value 10, 20, maybe 30 and 40, and p of x takes the value like this is 1 over 8, maybe 3 by 8, 3 by 8 and 1 by 8. Okay, so if this is the result of some experiment, right? So here you see that we don't have to be specific about what experiment you are doing, correct? We just have to look the possible values. Values are 10, 20, etc., 30, 40, right? And corresponding to each of them, we have some probability associated. That's all. All right. Now, so considering this, let's try to solve this. Okay, how do you calculate the mean? Now, if you want to calculate the mean, mu is equal to, this is sum of xi into p of xi, correct? Xi into p of xi. So how do you calculate that? What is xi? Xi is this value. You see that I is equal to 1, I is equal to 2, I is equal to 3, I equal to 4. Right? Using them, directly I should be able to write this. So how can we write that? This is equal to, so xi is 10 into its 10 into 1 by 8, correct? Plus 30 into 3 by 8 plus 40 into 1 over 8. So when we calculate that part, the mean here comes to be 25. Now we'll go ahead and calculate its variance. Okay, the variance equation says that this is the summation of the x value minus its mean, the whole square, multiply that with the probability p of x, correct? So it means every term needs to be subtracted. You are subtracting the mean from that. In the sense, this is, first number is 10, I subtract 25, the whole square, into its probability, that is 1 by 8, correct? The same way, plus this is 20 minus 25, the whole square, and you multiply that with 3 by 8. Okay, so this is plus 30 minus 25 into 3 by 8. Oh, this is a square, right? Plus 40 minus 25 square into 1 by 8. Right. So this gives an answer equal to 75. Right. So like this, we can calculate the mean and variance of any event. So mean and variance takes a very important role in all the calculations related to the random processes. Okay. Again, we can extend this further to calculate the standard deviation. Sigma is equal to root v. So that is root 75 equals to what value we are getting? 8.66, right? All right. Now, fine. Let's try to go for. All right. Let's try to look at a continuous case. All right. So this is a question. So maybe a random variable, so that is capital X, has a p of x distribution function is 2 to the minus x. Okay, this is the probability density function with the, say, x taking the value 1 2 3 4 dot dot dot, any value you can take, right? So the question here is to find what is the probability. Okay, find the probability that this x is even, is what? Okay, and I'll ask him the question, p of the x is divisible by 3. And maybe one more. What is the probability that the x that you get is greater than or equal to 5? Okay, so this is the question. We are supposed to find what is the chance that the random variable x is taking, right, some numbers. What is the chance that this is an even number is the question. So let's go to the first one. It's straightforward. I don't have to calculate any complex this thing. It's very straightforward. So probability that the x is even, which means I know that the x value you are going to substitute will be an even number, correct? It's 2 to the minus x is the given function. So this can be, it's even means I have to add all the probabilities of even calculation, correct? So this is, I just write summation, the x being even, right, till infinity, right? Because upper limit is not mentioned, it can take any value. It's simply p of x, right? Which means I am supposed to write p of x is 2 to the minus x. So this can be 2 to the, starting from 2 to the minus 2 plus 2 to the minus 4 plus 2 to the minus 6 plus dot 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 dot. Correct? So when this is 2 to the power minus 2 minus 4 minus 6, you add up, what do you get? I simplify this. This becomes easy for you now. This is 1 by 2 square plus 1 by 2 power 4 plus 1 by 2 power 6 plus dot dot dot. Now this is easy, right? It looks like which type of progression? It's a specific type of progression. It's like a to the power is being increased, a square, a square, a square. A is equal to 1 by 2. Okay? This is summation a to the n. If you remember, right, summation of a to the n is nothing but a by 1 minus a. What is a? A is 1 by 2 whole square divided by 1 minus 1 by 2 the whole square. Okay, that's 1 by 4. 1 over 1 minus 1 by 4 is 3 by 4. So 1 by 4 over, I think, 3 by 4. So this is 1 by 3. 1 by 3 chance that this p of x getting is an even number. Okay, straightforward. Let's go to the next part. What is the chance that the x is divisible by 3? X is divisible by 3 means what? It should be either 3 or 6 or 9 and so on. Correct? So it's the same thing they are asking in a different fashion, only the calculation will slightly vary. So x is divisible by 3 means this has to be, once again I just write x taking a value 3, 6, 9 dot 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 till infinity. It is 2 to the minus x. So this means it has to be 1 over 2 cube plus 1 over 2 power 6 plus 1 over 2 to the 9 and so on. Right? So calculation is, once again it remains same, 1 by 2 whole cube divided by 1 minus 1 by 2 the whole cube. Okay, so 1 by 2, it's 1 by 2 be 1 by 8. Okay, divided by 1 minus 1 by 8, it should be 7 by 8. So this is 1 by 7. There is 1 by 7 chance that, right, the x you choose is multiple by 3, divisible by 3. Sorry. Okay, now the question becomes very interesting. The third part, which says that the probability that you choose some x which should be greater than or equal to 5. What is the chance that the x you choose is greater than 5? Okay, please think about this. Right. So here, the solution is like what you are supposed to calculate is 1 by 2 to the 5, right? 1 by 2 to the 6. That goes till, right? Till infinity. I know that this, right? From if you add this from 1 to infinity, that is equal to 1, correct? So what I do here, you do the reverse, right? I think initially you told the same answer, right? That is 1 minus 1 means it is from 2 to the 1, 2 to the minus 1, 2 to the minus 2, 2 to the minus 3 till infinity. Okay. But that is 1. From that I have to subtract whatever that exists before this, right? That is, before this I have 2 to the minus 4, right? 2 to the minus 3, 2 to the minus 2, and 2 to the minus 1. It's all the values greater than 5. It means I have to subtract 1, 2, 3, 4. Okay, so we just have to do this calculation, and I think we are going to get a value is 1 by 16. Okay, that's the answer. That's all for the day. Feel free to contact if you have any doubts related to any topics in engineering. We can also help you in solving your assignments, projects, and many more. Thanks for watching. Good day.